Factoring is a concept that deals with positive integers or whole numbers. For example, the number 50. Its factors are the numbers that it can be divided by. So anything can be divided by 1. You can also divide 50 by 2. You can divide it by 5, 10, 25, and 50. So these are all the factors. And actually, factors come in pairs. You see that 1 and 50 together, if you multiply those, you get 50. 2 and 25, and 5 and 10. As another example, let's take the number 16. Here, our factors are 1, 2, 4, 8, and 16. And again, you can pair them off, 1 and 16, obviously. 2 times 8. And here, 4 pairs with itself, 4 times 4. So factors are always going to have pairs. Sometimes the middle one pairs with itself. When that happens, it's called a perfect square. Prime factors are another way of doing factorization. Now, to begin talking about prime factors, we should first discuss what are prime numbers. And prime numbers are simply those numbers that cannot be divided by anything else aside from itself and 1. So, for example, and it must be larger than 1. So 2 is prime, 3 is prime, 5, 7, 11, 13, and so forth. So these are the list of prime numbers. And prime factors then, for example, 50, if we want to split that into its prime factors, what we do is we break it up into, for example, 2 times 25. And we say, can either of these be broken further? Now, 2 cannot be split up anymore into smaller factors, so it's prime. And 25, though, can be split up into 5 times 5. And those are both prime. So then we would say that 50 equals 2 times 5 times 5, and these each are prime numbers, so these are the prime factors. Now, this is related to the list of factors above in the following way. If we take any combination of these prime factors, that will get us one of these factors above. Let me give you an example. If we take 5 times 5, that's 25, and 25 is in the list up here. All right, if we took 2 times 5 is 10, and that's right there. So in fact, we can get everything in this list just by taking combinations of these prime factors. That's how they're related. Let's do 16. 16 factors into, well, we can do 4 times 4, as we had shown in the picture of the square above. And these are not prime. 4 is not prime, but it splits into 2 times 2. And this 4 splits into 2 times 2. And those are each prime. So the prime factors of 16 are 2 times 2 times 2 times 2. Now let me point out that it's important that you keep all copies of the factor 2 here. It's not like this list above where we just listed all factors and we never listed the same number twice. When you do prime factorization, you have to keep all of them because when you multiply these together, you should get back your original number. Now the next thing I want to do is talk about how you would use prime factors to calculate a couple of important quantities. The first one being the greatest common factor. The greatest common factor simply means of these list of factors, what's the largest number that's in both lists? If you look at these here, you'll find that 2 is the greatest number in both of these lists. So that would be the greatest common factor between 50 and 16. You can actually have greatest common factor between 3 numbers. It doesn't just have to be 2 numbers. You just factor all 3, find the biggest number that's in all 3 lists. Now, to demonstrate how we would use prime factors to calculate this greatest common factor, I want to do a larger example. These examples are too small. They don't show you the benefit of doing the prime factor method. So let's make a much larger example here. So let's factor the number 120. Okay. Now, if we do it the hard way, I'll do it first the hard way, the simplest way. Just list out all factors. 1 is always a factor. 2 is a factor of 120. 3 divides into 120. 4 does. 5 does. 6 does. 7 does not. But 8 does. 9 does not. 10, 11 does not. But 12 does. Now, we'll notice we're now big enough that we've actually, 10 and 12 are a pair. So to complete this list, all we have to do is find all the remaining pairs. 8 times what is 120? That's 15. That's a long list. Okay, so that was the hard way. Now, what is the easy way? The easy way is to take our 120 and just start splitting it up. I like to think of this as smashing it with a hammer and seeing which ways it breaks. it can break into a 10 times 12, for example. And then we can say, does 10 break anymore? Well, 10 breaks into 2 times a 5, and those are both prime. How does 12 break up? 3 times 4. 3 is prime, but 4 is not. 4 breaks into 2 times 2. Now we've got all the primes. Look how quick that was. So we have 2 times 5. I'm just writing the list of all the primes that we see below. That is the prime factorization. Notice if we multiply all these, we get 120. Now, it's often that you want to just sort these, so you can write it in one simple organized way. Let's put all the 2's first, then 3, then 5. Okay. So, and there's a notation. If you like this notation, you can actually take all the 2's that are together, and you can write this a 2 with a little 3 above it. That's just a notation that means 2 times 2 times 2. You call the 3 the exponent. This is 2 to the third. Okay, so you could write it this way if you wanted. This is a more compact way of writing it, but I'm not going to bother to use that notation. Now, again, if we wanted, this whole list is made of just taking different combinations of these prime factors and multiplying them together. For example, if you take the 2 times the 3, you get 6, and you see that 6 is in the list. Okay, so everything in this list is just combinations of these. Let me demonstrate that you could do this factorization another way. There's many ways to do it, and you'll always get the same answer. And this was just to convince you that even if you did it a different way, you're going to get the same answer. The old-fashioned way to factor 1,000 would be just to list out, okay, so that is another huge, long, terrible list. We'd rather not have to do all that work, and the prime factoring is, thankfully, much easier. So you have 2 and 500. There's the factorization, much easier. Okay, so we factored these two numbers, 1,000 and 120. Now let's talk about the greatest number in both lists. Okay, now if you look at this list, and now I'm going to scroll up, and you look at the other list, and you look for the biggest number in both, you'd see quite a few things in common. For example, 8 is in both, but actually the largest one is going to be 40. Okay, so if we were willing to do all this work to make these long lists, then 40 would be the number we're searching for. Okay, so we have the greatest common factor equals 40. Now, let's pretend we didn't do all that work. We did the prime factorization, which was much easier. Then what did we have? We have, let me rewrite since you can't see both numbers on this screen. Now, the greatest common factor, in fact, is found with a very simple trick. What we do is, remember, all factors are made by looking at subsets of these prime factors. So, in fact, what we do is we say, how many 2's are common to both of these factorizations? They both have 3 2's, so our greatest common factor will also have 3 2's. How many 3's are there? This one has 1 3, and this one has 0 3's. So I don't put any 3's in the answer here. How many 5's? We have 1 5, and we have 3 5's. So the smaller of the two is 1 5. Okay, those simple steps are all I needed to calculate the greatest common factor. The greatest common factor then is 2 times 2 times 2 times 5. That's 8 times 5, 40. Voila. Now, there's another important quantity that is kind of the opposite. Multiples of 120 are all the numbers you get by counting by 120. 120, 240, 360. So these are all 120 times some number. Just keep counting by it. The multiples of 1,000 are easy. They're easy. Just 2,000, 3,000, 4,000, 5,000, ... Okay, so these are the multiples. Now, you sometimes want to know the smallest number that appears in both these lists. One place where you'd want that is when you're finding a common denominator in fractions. Okay, so this is an important thing to be able to do. So what we have is the least common multiple equals, you do the same trick, you go up here and you say how many 2's are in these factorizations, and you take now the greater of the two rather than the lesser. So there are 3 2's in both, so 2 times 2 times 2. How many 3's? Well, there's 1 3 and there's 0 3's. So you take the greater of those. You take 1 3. How many 5's? You have 1 5 and you have 3 5's. So take 3 5's. Okay, so we see 3,000 right there in the list of multiples. We wouldn't see it in this list for a while. We'd have to keep going, and we'd eventually see 3,000. And that is the least common multiple.